Okay, welcome back. Let's take a look at page 3 of 1.2, talking about functions. And I remember sitting in class making a very common mistake that I'll see and being embarrassed about it later because it showed a definite lack of understanding. I just wanted to memorize things. I didn't want to understand them. Find all the values of x such that f of x is 0. And then a lot of times we want to put 0 into the function and put the 0 right here, but it says f of x is 0. F of x is 0. So 0 equals 5x plus 1. Oh, that's easy. Solve for x. X equals, it was 0. I need to subtract 1, and then I would need to divide away the 5. And that is it. So if f of x is 0, the first thing I might do is multiply both sides by 7, or you could think of cross multiply. I get 2x minus 3 equals 0, and therefore x equals, I would need to rescue 3 with addition, and then 2 with division. And how's that? Not like, I mean, these can certainly be more difficult. But pretty straightforward and very similar to what you have on 53-55. Now, the biggest sticking point maybe in this entire chapter is the issue of domains. In our factories, we have to make certain that nothing goes into our factory that might break the factory. So let's say this is a factory that takes things and puts them underneath 2. Can I put any number I want under 2? Like, can I divide 2 by a positive number? How about a positive really big number? 2 divided by 1,000,000. Yeah, we can do that. How about a negative number? 2 divided by a negative? No problem. How about 0? Can I take 2 and divide it by 0, or will that break the machine or the factory? Oops, excuse me. 2 divided by 0 breaks our factory. We cannot divide by 0. Therefore, our domain here would be x does not equal 0. So we'd have to have a sentry elf standing out here, and if you try to deliver a 0, say, hey, listen, we can't accept zeros. It'll shut us down. For right now, our biggest issues are denominators can't be 0. And how about this? How about square root of x? Can I put any positive number in there I want, like square root of 1,000, square root of 1, square root of 0.3? Can I put 0 in here? Well, sure, square root of 0 is 0. Can I put a negative in there? Oh, yeah, you say, well, we can put in negative 4. That would be negative 2, but that's not true because negative 2 times negative 2 does not give me negative 4. So square roots, in this case the domain would be x is greater than or equal to 0. So with that, if we get a function that we're not comfortable with, you can just kind of order of operations and ask yourself, can I square any number I want? Yeah, we can square 0, we can square positives, we can square negatives. Can I multiply any number I want by 2? And the answer to that is yes, we can. Can I take the opposite of positives, negatives, and 0? Yes. Can I add 1 to any number I want? Yes. There's no problem with this factory. It's going to be fine. In fact, if we knew what the graph is, I talked about this on page 2, if we knew that the graph of this looked like this, we could assume by that it goes on forever to the right and on forever to the left. That means all x values are on the graph. So the domain is all real numbers. And we'll write that so often that there's a nice abbreviation for that. And it's a lot like in writing, you've probably seen this. That's a symbol for paragraph. All real numbers, we'll use that to mean all real numbers. Okay, so the things I need to do to y, I ask myself, can I multiply any number I want by 3? Yes. Can I add 5 to any number I want? Yes. Can I divide a number by any number I want? No, I cannot divide by 0. Therefore, y plus 5 may not equal 0. So y may not equal negative 5. And we see that if I put negative 5 in here. Let's go clear. Let's go on. Second quit. Clear. Alpha window. Whoops. Fraction. So I get 3 times negative 5 over negative 5 plus 5, and ask my calculator to handle that. It doesn't like it. You can't divide by 0. Okay? So, I'm sorry, this isn't, is it a function or not? So this is y may not equal 5. Okay, 62, and you'll notice I put some more space in there. It really kind of ups the ante on what we're doing here. Interesting things happen. Can I square any number I want? Yes. Can I multiply any number I want by 3? Yes. Can I add any two numbers together? Yes. Can I take an even root, like a square root, fourth root, sixth root, etc., of any number I want? I can't take even roots of negatives. Therefore, x squared plus 3x has to be at least 0. And to solve that, it's been a while. I'm going to set this equal to 0. Solve that. I'll factor out x. So x equals negative 3 or x equals 0. Coming back to you. All right, and then I'm going to put those on a number line, and I'm going to make sure 0 is the bigger one. I'm going to put 0 to the right, negative 3 to the left. If I put 0 in here, I'm okay. I get the fourth root. I get the fourth root of 0, and I can do that. And if I put negative 3 in here, I get 9 minus 9, I get 0. Those ones are okay, so they get a solid dot. And now I'm going to test something in between. What happens when I put in, let's say, negative 1? Negative 1 gives me, inside the fourth root, I get positive 1 minus 3, negative 2. This is a bad zone. Can I put something bigger than 0 in there? If I put 1 in there, I get 1 plus 3, 4. Good zone. How about negative 4? 16, positive 16 minus 12, 4. This is a good zone. So we could answer this a couple different ways. We could say x is less than or equal to negative 3, or x is greater than or equal to 0. And that's probably what you're used to. There's also what's called interval notation, and this is going to become really useful, and this will be used exclusively for these types of problems in calculus, where we just say, hey, let's start over here toward approaching negative infinity. It exists, it's good until here, and then starts again from 0 up to infinity. And we would say negative infinity to negative 3, and I use a hard bracket to mean negative 3 is included. If negative 3 was not included, I use a parentheses. Or is a union symbol. And then we start up again. It's always left to right. Negative infinity to negative 3, or 0 including 0 to infinity. There's our domain. Okay. Our solution guide probably has that, and I can live with that for now, but you're going to see this from me every single time we do a problem like this, and eventually we're going to exclusively use it. Okay, number 64. Can I square any number I want? Yes. Can I multiply any number I want by 2? Yes. Can I subtract any two numbers I want? Yes. Can I divide by any number? No. X squared minus 2x may not equal 0. X times x minus 2, let's find out when it is equal to 0. That happens when x equals 0 or x equals 2. Create 0 in the denominator and we have problems. Therefore, our domain is x cannot equal 0 or 2. There's ways to do that with interval notation, but typically we'll do that when we actually have intervals, not just specific little values. Okay, and this one, 66 raises the ante a little bit too, because we got a couple things to consider. First off, the numerator, for our numerator, x plus 6 has to be at least 0. Therefore, x has to be bigger than or equal to negative 6 in our numerator. For our denominator, 6 plus x cannot equal 0. We can't divide by 0, so x cannot equal negative 6. Negative 6 is fine in the numerator, but not in the denominator. Therefore, this is telling us you can be negative 6 and to the right, but this is saying, well, you better not be negative 6. Everything else is good. Final domain, x is greater than negative 6. Like, here's the numerator. The numerator at negative 6 is good. And here's the denominator. Negative 6 is bad and everything else is good. Where's it good? To the left of negative 6. Interval notation, that would be negative 6, not including negative 6 to infinity. Okay, a couple new things there, and we will pick it up with page 4 shortly.